Let's finish up 11.1 Goal 3 with example number 3. Remember, our goal is to calculate the limit using a table or the algebraic method. So we're finding the limit as x approaches 1 of this piecewise function. Now I am going just to review with you how to graph this without your graphing calculator, and then I'll show you how to graph a piecewise function on your graphing calculator. Let's begin by sketching the graph of 2x when x does not equal 1. That means x can equal any value except 1. 2x is a linear function. It has a y-intercept of 0. So we'll start with our y-intercept of 0, and then our rise over run. Our slope is up 2, right 1. And remember, because x cannot equal 1, we have an open circle there. And then our slope up 2, right 1. We can go back to the origin and down to left 1, down to left 1. So let's draw that line. And now let's graph -2 when x equals 1. So this is telling us that our function is -2, so y equals -2 is a horizontal line across -2. However, it says that x can only equal +1, no other value. So we just have an ordered pair at 1, -2. Let me explain that one more time in case you missed that. Our function is y equals -2. We know that y equals -2 is a horizontal line. However, our domain says that x equals 1. That means x equals 1 and only 1. So that gives us an ordered pair, right 1, down 2. So let's try to find that limit. This one's a little bit tricky. As x approaches 1 from both sides, you have to decide, am I going to approach 1 on the ordered pair on the ordered pair 1, -2? Or am I going to approach 1 along this linear function? Well, it's impossible to approach x equals 1 at the ordered pair because that is a point. It is an ordered pair. And we're not looking for the value of y at the value of 1. We are looking for the value that y is approaching as x is approaching 1. So let's only look on the linear line. So as x approaches 1 from the left, y is getting closer and closer to 2. As x approaches 1 from the right, y is getting closer and closer to 2. So this tells us that our limit is 2. Let's check that with a table. And let me say right here, whenever I tell you to solve using the table method, you do not have to do it graphically first. You can go straight to the table. But I just wanted to review the graphic method since we learned that today as we were going through this. All right, so we're approaching 1. So 1 goes in the middle of my table. Remember, we add a thousandth to the right, a hundredth, and a tenth. And then on the left-hand side, we subtract a thousandth, and we subtract a hundredth, and a tenth. And let's let our table do the calculations for us, or let's let the table on our calculator do the calculations for us. To enter a piecewise function, you want to first open the piecewise function template. If you'll find 9 on your keypad and go 1 button to the right and press that, that opens up different templates. Okay, follow my blue box, and the box that is highlighted blue right now represents a piecewise function that has 2 equations. I know this is a piecewise function because the first box allows me to enter the equation. There's a comma, and followed by that is the second box where I enter the domain. If I had 3 equations, I would use the template that's blue at this time. Okay, so let's open this template. Remember, our first equation is 2x. Our domain is x does not equal 1. To find the not equal to symbol, press Control equal, and it brings up not equal to 1. There's our domain for the first equation. The second equation was -2, and its domain x equals 1. Notice that it graphed our linear function, but it did not graph our ordered pair, -2, 1. So that will also help you when you're calculating the limit. Let's go to open our table and enter our values. Remember Control T or Menu Table. To change our settings so we can enter our x values, remember the key functions are Menu, Table, Edit Table Settings. We want to change the independent to ask. Don't forget to enter your x coordinates in chronological order, so either smallest to largest or largest to smallest. Your preference on that. And then transfer your y coordinates onto your table right now. Now that we have transferred the function values or the y coordinates onto our table, let's analyze. Remember, to calculate the limit, we check the limit from the left and from the right. So as x gets closer and closer to 1 from the left, y is approaching, we have 1.8, 1.98, 1.998. So y is approaching +2. As we approach from the left, y is getting closer and closer to 2. Let's go to the right. As we approach from the right, our y coordinate is 2.2, 2.02, and 2.002. So as we approach 1 from the left for x, y gets closer and closer to +2. Because our left limit and right limit are approaching the same values, they are equal, we do confirm that our limit is +2. Now I want to make it clear, do not let the value at x equals 1 cause you to be misled about the limit. Remember, when we are calculating the limit, it's the value that we are approaching, not necessarily the functional value at that point.